we're going to live code a bloom filter. First thing I'm going to do is make our bloom filter class. And it's going to have two methods, insert and may contain. And right away, I'm going to import fire so that we can test this thing as we go. Okay, so what happens when we insert an object? Well, we hash the object a bunch of times. And we're going to need to get these hash functions from somewhere. And with the result of each hash function, we mark that result as having been seen. So we're going to have a tape of bits, and we're going to mark the bit that says that we've seen this hash function. And so if we ever see the same object, then we'll get the same values if we hash it with all the same hash functions. And if we check the tape at all of those locations, we'll see that they're all true. And so that's going to be the indication that the filter may contain the object. If any one of these is false, that means that we've never seen this object before, and so may contain will be false. So let's write that logic. So if any of these is not true, then we immediately return false. But if they're all true, then we return true. Okay, but we're missing those hash functions and the tape. Let's set that up. And let's also take the tape size as it. So the tape is going to be, it's going to start as all false, and the hash functions will come from the input. Okay, so let's make ourselves a bloom filter. We need some hash functions. Let's see. Let's use integers, and our hash function will be n squared mod 20 and n times 3 plus 7 cubed mod 20 will be our second one. I don't know if these are good hash functions. Saving this as bloomfilter.py. Let's give it a try. Right, there's no tape. I dropped an equal sign. Great. Okay, so now we can try inserting a number. Into our bloom filter. Self is not defined, so please get this state self. Great, it inserted 12. Oh, you can't see where I'm typing. Okay, let's go ahead and run this command. We insert 12, we insert 15. Now each time we're running this, it's starting a new process. They're not staying inserted. So if we check may contain 10, it says true. Now it should have said false because everything should start as false. If any of these is false, then we return false. If any of them, so yeah, we should be returning false right away, but instead we're seeing true. We're hashing. It's because we don't have any hash functions. So let's give ourselves 2 hash functions. And now that's false. Okay, good. So let's look at this interactively. So we have our Bloom filter, and now we can insert numbers, and since we're in the same Python process, they're going to stay. And so now if we check may contain 9, that's false, but 10 is true, and 12 is true. 13 false. Oops. If we insert 13 and then check it again, now it's true. Looks like we've got ourselves a working Bloom filter. We can look at the internals of it. We can see its tape. We've got true in slots 0, 5, let's see, 1, 2, I guess we can do some. I'm trying to figure out how many things have been set. So 6 things have been set because we have 2 hash functions and we've inserted 3 different things. I'm going to insert a few more things and check this. Okay, so now I inserted a 4th number and notice that only 1 additional bit in the tape has been set. So if I check may contain on the thing we just inserted, it's working. But now there are some false positives because our tape is starting to get crowded. So I've never inserted 14. We can check that. Yep, I've inserted 10, 12, 13, and 19. So why is it that 14 is saying yes, it may contain it? It's because the hash 1 of 14 is 16, hash 2 of 14 is 9, and both of those numbers, 16 and 9, are going to come up from some other number that I've inserted. So let's see, I inserted 10, 12, 19. What are the numbers? That's 10, 12, 13, and 19. 10, 12, 13. So that's where the 16 is coming from. And 19. Okay, and then if I check hash 1 of those numbers, one of them is going to say 9. 10, 12, 16, and 19. Sorry. 13. That's where the 9 comes from. So the number 16 came from 16. The number 9 came from 13. The number 16 also came from 13. And that is why when we checked, well, is 14 contained in the Bloom filter, it said yes, the Bloom filter may contain 14, even though we never actually inserted 14. And so that points towards the limitations of Bloom filters and also makes you start to think about how big should your tape be? Do you want more hash functions? Do you want a separate tape for each hash function, or is it okay to have a shared tape? If we had had a separate tape for each hash function, we would have been using twice as much space, but we would have avoided the collision because the values for 13 from the hash functions and for 14 came in opposite orders. Hash 1 of 13 was 9, whereas hash 2 of 14 was 9, and hash 2 of 13 was 16, whereas hash 1 of 14 was 16. So that's our Bloom filter. I think it's pretty cool that through the use of Python Fire, we didn't have to write a real main method in order to test out all the functionality. We just ran this interactive mode command, dash dash I, or dash 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 I, and that gave us an IPython environment that already had our Bloom filter available. It already had hash 1, hash 2, and we didn't even have to import anything.